Alright, logic fans, what's up? Welcome to our fourth and final video on section 5.5. So this is 5.5D, and we're coming to our penultimate notion in 5.5 that all of our groundwork has led up to. And recall that the single-handed most important concept in logic for us, right, is inference. And our analysis of inference is the notion of validity. And just like in chapter 2, where we said that an argument is valid if and only if on in every row of its truth table where all the premises are true, the conclusion is also true, right? There's no row of the truth table where all the premises are true and the conclusion is false. So we have a definition here that basically mirrors that, but for quantificational sentences. So an argument is semantically valid if and only if on every possible interpretation, every single one of them, without exception, the following holds. If all premises are true, then the conclusion is true. Okay? So, let's take a second here and think. Is semantic validity, based on what you've seen in the foregoing videos of 5.5, something that we can demonstrate? Pause now and have a think on that. Okay, semantic validity is not something we can prove. It's just not something we can prove, right? Because you would have to go through every single interpretation and make sure that this condition held. If all the premises are true, then the conclusion is true. That would be like going through every single possible interpretation and showing for every single one of them either at least one of the premises is false or all the premises are true and the conclusion is true. For every single one of them, okay? And there's just too many of them to do. You cannot do that, all right? But fortunately, what we can do is we can demonstrate semantic invalidity. So let's go ahead and define that notion. Now recall from chapter 2, we said an argument is invalid if and only if it is possible for all of the premises to be true and the conclusion false. We're going to have a similar definition here, if and only if there exists at least one interpretation according to which, if and only if there exists at least one interpretation which makes all of the premises true, all of them, and the conclusion false. Okay? So this is absolutely something we can show, right? Because it only requires the production of a single interpretation. And we've got this nice Tableaux technique available now, which we can do that with. So let's take a look at some examples and see if you can get yourself to prove that arguments are semantically invalid. So here's an example of an argument. Now, what's going to happen in situations like this, since you cannot prove semantic validity, okay, is that your professor is going to give you, like I have here, an argument which, as a matter of fact, is invalid. Your task is to demonstrate that it's invalid. And in order to do that, here's what must be done. You must provide one interpretation, at least one, which makes all of the premises true and the conclusion false. So let's use three objects as our example. All right, so pause now and see if you can demonstrate that this argument is semantically invalid. Okay, so here's a bit of a hint for you, so you can, here's the template you're going to use to solve this particular problem. And again, you need to make all of the premises true and the conclusion false. So if you couldn't get the template and you weren't sure what to do, you can pause now and try it yourself, but I'm going to walk us through this. So in this particular case, not necessarily in every case, but one thing I like to do, especially when I have, a universal quantifier in the conclusion, I know I want to make the conclusion false. So I just need at least one of my objects from my domain to not satisfy this description. So I'm going to start with that, and that will make the conclusion false. Okay, so you can think of it as trying to make this statement true. Okay, now I'm going to make this conclusion false, so I need at least one thing that does not satisfy this description. Let's choose the object C. It doesn't matter which one you choose, okay? So it's going to have the property F, but it's going to lack the property H, okay? So it's not the case that everything satisfies this description. C does not. So I've got a false conclusion now, okay? So maybe what I'll do is I'll put that in red just so we can keep track of our work, okay? So far we've made the conclusion false as desired, okay? Now what we got to do is we got to make sure all, without exception, every single one of the premises are true. So I don't know, let's start with this one. If f of x, if you're f, then you're g, right? So it's a categorical A statement, right? Now, we got to make sure everything is such that if it's f, then it's g. So for A and B, it's kind of easy, right? We can just make sure that they have a false antecedent here. So A is going to satisfy this description because it's not f, right? And B is going to satisfy this description because it's not f. So if you're having trouble following that, you need to go back and look at the previous videos in chapter 5 here on Tableau techniques, okay, and really do those problems. I'm taking all of that for granted now. So A and B satisfy this description, right? But it's everything, so we need to make sure C satisfies it as well. Since C has the property f, we have no choice but to go ahead and make C have the property G, okay? And so that makes the first premise true so far, okay? So if you're sort of tracking what we're doing, we've now got a false conclusion as desired. We also have one of our two premises true, but the definition requires us to make all the premises are true, so we have to ensure that consistent with all of this so far, the second premise is also true. And sometimes, okay, when you get into more complex cases, you're going to have to do some trial and error, okay, to get it to work. But the easiest thing to do in this case, in order to ensure that everything is such that if it's H, then it's G, to make sure everything satisfies this description, is just to make everything lack the property H. Okay, so here's an interpretation according to which all the premises are true and the conclusion is false, and therefore, right, we've proven that this argument is in fact semantically invalid. So you can prove that an argument is semantically invalid. This is how you do that. You cannot prove that an argument is semantically valid because there are too many possible interpretations to go through. Okay, let's try another example. Okay, here's an argument, okay? It's invalid, I'm telling you that. Your task is to prove, to demonstrate that it's invalid, and once again, you do that by producing at least one interpretation, let's say in 3 objects, just for example, okay? Which makes all of the premises true and the conclusion false. Pause now. Okay, let's go through this together. If you haven't had a chance to do it, you can sort of start here. Here's your clue. Here's how you're going to set this thing up, okay? Now, what we need is all the premises to be true and the conclusion false. Now, in this case, my premises, which I need to be true, have the existential quantifiers. And so I'm going to start with them because that's pretty easy to do. I need at least one thing that satisfies this description. I need at least one thing that satisfies this description. Now, if I could make both of them true with one object, that's what I would do, just strategically. But in this case, I can't do that. So I'm going to have, my object A is going to make the first premise true, and my object B is going to make the second premise true. And there was no rhyme or reason as to why I picked A and B, but that's what I'm doing there, just to sort of get myself started, right? So far, what I've accomplished is making both the premises true. Now, consistent with that, I've got to ensure that the conclusion turns out to be false, okay? So I can't have anything in my domain that's this way, right? I need it to be false that at least one thing is this way, so nothing can be that way. Alternatively, I need this statement to be true, okay? So nothing can satisfy this description. Well, already A and B do not satisfy that description because they both have F and we need something that lacks it. So if I just go ahead and ensure that C also has the property F, this would be an interpretation in 3 objects according to which all the premises are true and the conclusion is false, thereby demonstrating that the argument is in fact semantically invalid. Okay, I hope that's making some sense to you intuitively, and I hope you can sort of appreciate why I took the time to take us through all of the Tableau techniques, because it makes, doing this part much easier to understand what's going on. Right? And what's going on is, think about it from the perspective of the definition of validity. So semantic validity, right, says that, an argument is semantically valid provided on every interpretation, if all the premises are true, then the conclusion is false. Well, that doesn't hold, right? Because here's an interpretation of this argument, right? It's an interpretation and all the premises are true and the conclusion is false. So that test, the test for semantic validity fails. In other words, it's semantically invalid. Okay? Let's do another example here so that you can feel confident with this as you go into the exercises in the text. Okay, so here's another example. This time we're going to do some mixed quantifier stuff, and we've got some negations in there. The text builds up in complexity, so some of the later problems are harder than some of the earlier ones. After this section, we will be jumping into some techniques for how to they're called expansions. Once we learn how to expand these sentences, finding interpretations will become a little bit easier, especially for arguments that have premises and conclusions that are very complex with relations and identity statements going on in them and things of that nature. But for now, since you're just learning this, let's try this one, okay? So, this argument is invalid. Prove it, okay, using an interpretation with 3 objects. Pause now. Okay, so here's your hint. You can pause again now with this and see if that helps you, right? But we need the conclusion to be false, and we need all the premises to be true. So in this case, what I'm going to do is I'm going to start with this premise because it looks to be pretty easy. I need at least one thing that's not G in order for that to be true. So I'm going to go ahead and make that the object B lack the property G, and thereby make the second premise true. All right. I need to make the conclusion false, all right? So the conclusion says everything lacks F. So provided I've got at least one thing that is F, like that, for example, that's going to make the conclusion false, right? The conclusion says everything lacks the property of F. But here I've got something having that property, therefore the conclusion is false on this interpretation. So what remains to be done is to ensure that, consistent with all of that, the first premise turns out to be true. Okay? Now, in order to make the first premise true, the easiest thing is to go ahead and put minuses here in the case of B and C, and that will ensure that the object B satisfies this description and that the object C satisfies this description. But we got to make sure that the object A also satisfies this description because it's the universal quantifier. A already has the property F, so we're going to make sure that A has the property G, and therefore everything is such that if it's F, then it's G, right? So here's an interpretation in 3 objects according to which the argument has all true premises and a false conclusion, and therefore the argument is invalid and has been demonstrated to be invalid. All right, logic fans, so in summary and overview of our central semantic concepts, you got the notion of a logical truth. You cannot demonstrate that, but you can demonstrate that a sentence is not a semantic logical truth by providing an interpretation, just one, which according to which the sentence in question is false. Similarly, we've got a logical falsehood. Can't prove that either, but you can prove that a sentence is not a logical falsehood, and you can do that by providing an interpretation according to which the sentence in question is true. Okay, and all of this just flows straight from the definitions. All right, logical contingent you can prove. You have to provide 2 interpretations, one according to which the sentence is true, the other according to which it's false. Logical equivalence cannot be demonstrated, but that they're not logically equivalent, you can. A pair of sentences are not logically equivalent. You need one interpretation where one is true and the other is false. Here you need an interpretation according to which all the sentences are true, cannot show inconsistency. And invalidity, as we just discussed, you need one interpretation where all the premises are true and the conclusion is false. All right, logic fans, we'll catch you on the next video, 5.6, where we start our study of expansions.